Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with the topic solutions which is meant for class 12 CBSE. This is part 12 of the chapter. Today we will discuss about osmosis and osmotic pressure. Now see, osmosis is a process in which there is water moving through a semi-permeable membrane from a less concentrated to a more concentrated solution. For example, we know that in the case of plants, the osmosis allows it to absorb water and minerals from the soil through their roots. Also, if we see in case of preservation of food, we use sugar and salt. They are used as preservatives because they cause the microbes to lose water and decrease their metabolism. Similarly, when the resins are soaked in water, they swell. That is also due to osmosis. So what we find is that there are some membranes like parchment or cellophane which contain a network of holes. These holes are submicroscopic. Small solvent molecules like water, they can pass through the holes, but passage of bigger molecules which are solutes, that will be hindered. So solute molecules cannot pass through. So we call it as semi-permeable, means it will allow or permit some of the substances but it will hinder some other molecules. So these membranes are known as semi-permeable membranes. If this membrane is placed between the solvent and solution, so one side this is a container, in this is the semi-permeable membrane. On one side we take the solvent and in another side we will take the solution. So it is placed between solvent and solution. We find that the solvent molecules will flow through the membrane from pure solvent to solution. If this is solvent, the molecules will be moving to the solution side. So we find that the molecules will flow through the membrane from pure solvent to solution, from solvent side towards the solution. This process of flow of the solvent is called as osmosis, and this flow continues till the equilibrium is reached. Now, if we want to prevent the flow of solvent molecules, then we have to apply some pressure. So the pressure which just prevents all the flow of solvent is equal to osmotic pressure of the solution. If we want to prevent the flow of solvent, we have to apply some pressure. So that pressure which just prevents the flow of solvent is equal to osmotic pressure of the solution. The osmotic pressure depends upon concentration of the solution, and in case of dilute solutions, the osmotic pressure will be proportional to molarity of the solution at a given temperature, proportional to molarity of the solution at a given temperature T. So we can state pi equal to CRT, where pi is the osmotic pressure. Pi is the osmotic pressure and R is gas constant. R is gas constant. Pi is given as N2 by VRT. We know PV is equal to nRT. Pi is equal to N2 by V into RT. Pi is equal to N2 by VRT, where V is the volume of the solution in liters. N2 is the moles of solute. V is the volume of solution in liters containing N2 moles of solute. If we have W2 grams of the solute whose molar mass is M2, molar mass is M2 of the solute, and what is the amount of solute present? W2 grams. It is present in the solution. So N2 will be W2 by M2, that is amount of the solute given divided by its molar mass. We get number of moles. So we can say that pi v is equal to nRT, N2RT. This is for the solute. So in place of N2 we can write W2 by M2. So what we get, pi v is equal to W2 by M2RT. Now we just change the positions. M2 goes here, pi v comes down. So M2 equal to W2 RT by pi into V. M2 is equal to W2 RT by pi into V. Pi is osmotic pressure. Now two solutions which have same osmotic pressure at a given temperature will be called as isotonic solutions if the osmotic pressure is same. When such solutions are separated by a semi-permeable membrane, means we take two solutions which are isotonic and they are separated by a semi-permeable membrane, osmosis does not occur because same osmotic pressure. So no osmosis occurs between them. If we place the cells in a solution which has more than 0.9% sodium chloride, 0.9% is mass by volume. Sodium chloride, water will flow out of the cells, water will move out, the cells will shrink. This is known as plasmolysis. Such type of solution is called as hypertonic. But if the salt concentration is less than 0.9%, when the salt concentration is less than 0.9% mass by volume, the solution is called as hypotonic. In this case, water will flow into the cells. Water will flow into the cells if placed in this solution, and the cells will swell, become bigger in size. Based on the above information, let us solve. 200 centimeter cube of an aqueous solution of a protein contains 1.26 grams of the protein. The osmotic pressure of such a solution at 300 Kelvin is found to be 2.57 into 10 to the power minus 3 bar. We have to calculate the molar mass of the protein. So first of all, let us write down the given information. Pi is given as 2.57 into 10 to the power minus 3 bar here. V is 200 centimeter cube, but 1 cubic centimeter is 0.001 liters. So 200 centimeter cube becomes 0.200 liters. T temperature given this one 300 Kelvin. R is 0.083 liter bar per mole per Kelvin. Putting all these values, we find that M2 equal to 1.26 gram into R value 0.083 liter bar per mole per Kelvin into T 300 K divided by 2.57 into 10 to the power minus 3 bar, that was pi value given, okay, that is pi, and this 2.57 into 10 to the power minus 3, 2.57 into 10 to the power minus 3 bar into 0.200 liters, that is the volume V. On calculating, we get 61.022 gram per mole. 61.022 gram per mole. This is the M2 value. I hope students you all could understand whatever I discussed today. Thanks for watching my video. Please share the video and subscribe to the channel. Please subscribe to the channel. Thanks for watching. Thank you.